for converting particles from grams to particles, that's what this problem is. It's going to be a two-step problem. So we're given 0.7206 grams of phosphorus. The molar mass of phosphorus is 30.974, so we'll call it 30.1. I'm sorry, 31. So 31 grams goes down there, 1 mole on top. We want our answer, though, in number of things, particles. So we use, excuse me, that 1 mole equals 6.02 times 10 to the 23rd of something. Then you multiply them together. So you take your 0.7206 times 6.02 to the 23rd divided by 31. And you get basically 1.4 times 10 to the 22nd. And the label there would be particles. Switching gears for the next problem, we've got a problem that is density related. We want to get our answer in milliliters. That's volume over the triangle. Density equals mass over volume. We want to solve for volume. That's what this milliliters is. So it'd be the 15 grams divided by the density. So take your 15 grams of ethanol and divide it by 0.789 grams per milliliter. And you do 15 divided by 0.789, 19.01 milliliters. The next problem, 3, back to conversions. It's a 5.296 mole sample of calcium phosphate. How many grams is that? We need the molar mass of calcium phosphate. Oops, that's phosphite, sorry. So calcium is 40.1, and there are 3 of those. And then this 2 distributes, so you have 2 phosphoruses, which is 31 times 2, and then you have 6 oxygens, which is 16 times 6. So about 278.3. And then moles cancels out, and you multiply here, so take that number times the 5.296. You got 1473.9. And label will be grams. And number 4, what's the final temperature of a 20 gram sample of aluminum? That's a specific heat. It accepts 500 joules of heat at 22 degrees Celsius. So it sets up like 500, we're using specific heat. Q equals MC delta T. 500 joules equals 20 gram sample. Specific heat of aluminum is 0.897. Final temp is what we're solving for. Initial temp was 22 degrees. So there's your setup. And the math involved is 500 divided by 20 times 0.897. You got to add the 22 back in. 500 divided by 20, 0.897 plus 22, 49.9 or so, 49.9 degrees Celsius, because we're in Celsius for this problem. And finally, for the molar mass of sodium sulfate, you just got to add it up. So from the periodic table, sodium is 23, there are 2 of those, sulfur is 32, and oxygen is 16 times 4. So you add those up. 23 times 2 plus 32, 16 times 4. About 142 or so grams per mole. Happy studying. Bye!